very good evening to you all. This is the penultimate session, so I'll try to keep it as interesting as possible. We have a very interesting speaker after me. Thanks for this opportunity, nasscom. We are a very early stage startup. We got this opportunity. I said we'll do it. So this is going to be a little bit very different from what you have heard probably. It'll be very interesting to have some discussions after that. So we are talking about sustainable mobility, transportation at large, right? So as they introduced, I'm a scientist turned entrepreneur, very young, 46. So we will start off with where it started. Basically, I'm a scientist who built MRI scanners for a long time. I was with Philips. Before that, I was in academic research. But this issue of transportation, especially in a city like Bangalore, I'm from Bangalore. I was actually born very close to this place. This was bugging me for a long time. As somebody said, you need to be really crazy to do something like this. So I'll just share the craziness we have embarked on. I'll be inviting you to share your thoughts later. Right. So why do we need to make transportation infrastructure sustainable? Why is it even important? We have heard this a lot. It's a huge energy guzzler. 25% of all the energy that is generated worldwide goes for transportation, right? It is still contributing to pollution. Obviously, electric vehicles will address some of those issues. But there's another sinister thing we have, congestion. India has a lot of congestion-related issues. Bangalore and Pune are two cities in the top 10 in the whole world, which are known for congestion. We lose a lot of revenue. Just the productivity loss we have because of congestion is huge. And of course, a lot of people get injuries. They even die out of road accidents. This is a sector which has disproportionate influence on everything we do, quality of life, in fact. So that's why it really takes a huge position in what we call a sustainable development goal. So if we can do anything in this area, we feel it's going to be a really good thing for not only our country, for the whole world. So just a quick show of hands. We all know public transportation is sustainable, green. How many of you used at least partially a public transportation means today? I'll just put up my hand. I came by metro. Really nice. I guess most of you took a metro because it was close by, right? Although we know public transportation has a lot of issues, just because it's faster, we are willing to take it. You may not get a seat. You may not get the kind of seating you want, or you can't sit with multiple people. No, you don't get any of those things, but still speed matters here. Likewise, although there are a lot of issues, there are still some benefits. If you take private vehicles, it's amazing. You can drive, but you're wasting 1.5 hours. That's utterly useless if you're traveling a long distance, or you need to pay a lot if you have a chauffeur. That's not a great solution either. And now you take ride hailing, Ola or Uber. As long as there's no rain in Bangalore, everything works. The moment it rains, you have no Ola or Uber. I don't know what happens to them. They just vanish, right? So, that's what we're talking about. So we don't have a very reliable system which works all the time. So this is the prelude. I'll come to what I'm getting onto. You're all engineers. A lot of you are software engineers. You're better placed than me to appreciate what internet does internally, right? How it works. So you have an internet on which you have fiber optic cables which go all around the whole world, in fact, connecting computers, passing information as messages, and there are algorithms which do this. And you don't even have to think about them, right? It's working flawlessly. Imagine if you could do that for transportation. It's a crazy idea. If you could move people and goods like that, if you could move people and goods like you move data on internet, what would it do for us? Essentially, there's a lot of parallel between transportation and data movement. Of course, you can't have packet losses here, otherwise you'll be messed up. Except for that, you can actually try to leverage a lot of the things we have learned, and that's what we're trying to do at BritFlow. So instead of speaking a lot, I'll just say we're trying to mimic an internet for transportation. It's in the physical space. It's a cyber physical space. I'll just play a short introduction so that I don't have to speak a lot. We can at least see something. I'll just stop it there. I hope you got a better idea of what I was trying to say rather than me speaking. So how many of you thought this was Hyperloop? Show of hands, please. I'm really sorry to disappoint you. We are not a Hyperloop company. So it's very different. It's much simpler. We call ourselves as an Internet of Transportation infrastructure because we are trying to build something which is connected, autonomous, shared, and electric by design. So this is the North Star of transportation. And we're trying to build it for public space, including public transportation. And we're not using vacuum, magnetic levitation. We are not running at very high speeds. Hyperloop is competing with airlines. They're really a point-to-point. We are mostly a very simple technology which is running on rails right now. We can go up to 60, 100 kilometers per hour. But it's mostly about urban transportation, shorter distance transportation. We can go for a little longer, but we are not in that space. I just want to be clear about that. And the main point here is to make this as small and nimble as possible so that it reaches every household, or at least every block, not household, block. So that means you can have a non-stop block-to-block commute with public pods, like your private vehicle. And you don't have to be worried if when it rains, it comes, because it's autonomous. If you have one, you will get it. Assured cost and availability is something which we want to provide with this, right? So as you can imagine, this is an infrastructure project. So there's no software, hardware, everything under engineering comes here. So we are a very small team. We're trying to build what we have. If this works, what does it mean? Basically, people who use public transportation, they get a private transportation with a public pod. Fast, non-stop, high-quality private commute. For people who use private transportation, they don't have to drive, they don't have to park, they don't have to worry about, like how am I going to be there in time. For customers, mostly government, I would say, and also some private sector players, it can reduce your energy consumption significantly. We have made design changes which can give you 30% energy saving over electric buses. Overall, 45% reduction in greenhouse gas emissions. Really, this is a way to transition to green energy. And it's great on sustainability metrics and safety metrics as well. So in simple words, it helps uptake of sustainable and smart transportation. And if you see what sustainable mobility is all about, it's universal access, efficiency, safety, and green mobility. We tick all those boxes. So this is what we are trying to build. Of course, you can take this concept and apply in multiple places. Of course, cities and townships will be the hardest thing to do. But you can start off with industrial estates, you can start off with tech parks, tourism, other areas where it is easier to try to implement such a system. So that's all theory. As I said, we're a very small startup. We were 3 people till 2 months ago, now we're 8 people. I'll just show what we have done. So we've built a test bed. On that, we have been running pods, prototype pods, autonomously for the last 5-6 months. And we have built new pods. These are far better than the first one. They are also running now. Now, have we figured out everything? There's a lot to be done yet, but we are more than confident that this thing can be done well and scaled up well as well. So you can see a person sitting in there being moved around. This has been done multiple times. The new pods, test jigs, everything is in place. Now we are building a complete technology demonstrator, so to say. In the next few months, we should be having a full-fledged technology demonstrator. Right, this is a session on design. So I thought I'll just say what our thought process was when we were doing this. It'll be great to hear back from you later if you have any things to discuss, right? So I will not talk about the need and the benefits. I think I've emphasized that. The question is about the feasibility. I'm sure like everybody is thinking, this is a crazy idea. Where is it going to work? How is it going to work in cities, right? So we also have those doubts, but I'll say what we are thinking. It'll be great to hear back from you later. So the technical feasibility of the idea, I don't think being technical people, you would doubt that. This is doable. There are people who are going to send people to moon soon. We'll hear from them. But this is much simpler tech. Technology is not a problem. Unit economics, return on investment, definitely issues. Space constraints in cities. How are we going to deal with this, right? And there's a whole list of things that we need to do to make it work with the governments, with the private sector. It's a great opportunity for collaboration. You have to face policy regulation. There's none as of now directly relevant to India. Funding, willingness to try. Who would want this first, right? This is the kind of thing. Anyway, I'll talk to I'll talk about the unit economics a bit. As I said, we have a lot of energy-related savings, which we can pass on to the customers. And we use what we call as a third rail technology to just power the pods, which means we don't need very huge batteries or very expensive batteries. So we bring down the weight, we bring down the cost. And it's a distributed system. It's a demand-based system. It's not like a timetable-based system. So you save a lot of energy where you don't need to make trips. You don't need to make trips. That's it, right? And the price point of this, we will not know where it will end, but I can tell you it's very, very competitive compared to what we feel is reasonable today. We are guessing it will be somewhere between a auto rickshaw and maybe even an electric scooter. That's what we're aiming to in terms of energy. Quality of service, obviously, if we can manage this, this will be unprecedented in what we have seen in our lifetime, right? So for the investments in urban conglomerations, we estimate it will take about 6 years to break even if you run at 75% capacity. That's what we are seeing. We have done academic research as well on this because nobody believes when we say these numbers, so we have to go back to the academicians and say like, hey, we have done simulations, see this is what we find, this is the practice what we find. And luckily we have been called to present at a very good conference. They have accepted our paper. So hopefully these things will pick up soon. We have also done some feasibility analysis. Of course, it's pretty early. On the x-axis, lower is capex. On the y-axis, opex. We really sit at the lower left corner, which means any technology of this kind can really do well in terms of both capex and opex. So where do we put this, right? So if you're lucky, you have roads like this. We have somewhere a median. You can build something over there, and it'll work out if you have a road like this. But now what you have a road like this, right? It's very interesting. After getting onto this, problem-solving mode, every day when I travel, I see which road has electric poles now, because that's where you can put the stuff. So wherever you have electric poles, at least in Bangalore, they cut all the trees. They don't let them grow, right? So they're also changing the electric cabling now. They're removing it, and they're either putting it underground or they're making a single cable. So the proposal is, can we combine these two? I've been talking to an MP, and I said, like, maybe we can combine these two. You're wanting to put the cables elsewhere. We want that space. Can we get it, right? It's very interesting. That's still possible. We didn't know those spaces exist, but they exist. And this is real challenge. This is Avenue Road, which is probably one of the most crowded roads in Bangalore. And there, you still can build infrastructure. This is interesting because you don't get very large trucks there, so you don't have to go very high. And there is a small consortium of people who are thinking like this, just to say that we are not the only crazy ones. So we have been discussing this with the government, with institutions. So there's a possibility you can get space even there. So that is a deep penetration we want to achieve to make this possible. Of course, none of this is easy. None of this is going to happen tomorrow. But we don't want to cut trees. We don't want to use the footpath because we want people to walk. Still, we think we can make it work by using private space, right? That's the other angle to it. And this is theory. We need to work it out. We are talking. We'll see how this pans out. So I'll just slowly come towards the conclusion part. We want to be a developed country very soon. And we have overcome a lot of barriers. If you don't have water, we get water from 200 kilometers away. We manage it. We dig underground, we get water, right? We don't have problems there. We don't have electricity, we don't care. We get other options. We are fortified for all these things. No phone, no problem. You can get Starlink now, right? Even if you don't have good air, you can do something about it. You can still get an air purifier and feel that you're going to be okay. But we really hit a bottleneck when we don't have any more roads. This is something which is a real issue because we have already run out of roads. There's an infrastructure problem. It is no more a problem of just transportation. It's an infrastructure problem. No matter how many EVs we get, no matter if we get completely autonomous vehicles, this is not going to grow. We need to do something about it. And what do we do at this juncture is the question, right? We are building metros. Of course, that's great. We have to probably bring drones to move people. That's also great. What we are saying is, hey, here is another way of doing it potentially, which could be much more cheaper, which could be sustainable, right? This is an alternative way of doing it. And as if we were thinking of tomorrow, actually it is today. So these initiatives by the government are actually asking for solutions like this. So this is a tender actually on the right side from UP state government calling for people to install something called as personal rapid transit, which is relatively very close to what we are trying to do, right? So this is not something which is going to happen 10 years down the lane. This can happen now. They're asking for tenders now, but for some of them, apparently there are no bidders. So it's an open goal for all of us from the industry to see what we can do, to help India, to help the world overcome these challenges with sustainable transportation. So with that, I would like to just conclude and say a thank you. This is my team. We are a very small team. I'm the youngest in the whole group, right? You see that? So we have built this in the last 2 years, and we hope to come back sometime later with real better stuff, which we can showcase as something very close to your product. With that, I'd like to thank you all, and if there are any couple of questions, I've got myself 2 minutes. I'd be more than happy to answer.
What will be the better target, no?
Yes. Ideally, we would start with an industrial estate if possible, because that is an easier one. New layouts and any smart city initiatives would be something which we would like to get a foothold into. If there are any other questions, I would like to take it. And yeah, maybe we can catch up later. I'll be here if we really want some feedback and advice. Let's put it that way. Thank you. Thank you.